Hello everybody, I'm about to do Algebra 1, Lesson 2-2, Point Slope Form. All right, turn to page 35 of your note taker, and let's get started here. Paul and Seth know that one point on a line is 4, 2, and the slope of the line is -5. Each student derived an equation relating x and y. Paul is using y equals mx plus b. He plugs in the coordinate pair 4, 2, including the slope, solved, and got b equals 22, the y-intercept. Seth starts with the slope formula, gets the slope plugged in, and went ahead and put it into another form. Question: do the two equations represent the same line? Construct a mathematical argument to support your answer. So, different approaches, are they the same line? That's the question. All right, let's take a look at question B. Generate a table of values for each equation. How can you reconcile the table with the equations? Let's take a look at Paul's equation. Y equals -5x plus 22. And let's take a look at Seth's equation. -5 times x minus 4, close parentheses, equals to y minus 2. Let's create a table for both of them. I'm going to pick just 3 values just to test it out. I'm going to plug in 0, 1, and 2 into Paul's equation. And let's see what happens. Plugging in 0, I'll get 22. Plugging in 1, I'll get 17. Plugging in 2, I'll get 10. Or no, sorry, 12. All right, let's compare that to Seth's table. Here we go. Looks like Seth has a little more work after we substitute in some values. That's fine, we got it. Okay. Scooch on up a little bit. I need to isolate y, don't I? So I gotta move that the -2 to the other side, which means the actual work becomes +20 plus 2. +15, kind of do that in my head, plus 2, and +10 plus 2. After I move that -2 to the other side. Oh, look, get the same answers. Very cool. All right, how could you represent the equations to show they are equivalent? Well, we kind of did the table. I just want to point out that what we're getting to is Paul has been using mx plus b. We all know that as slope-intercept form. And what's new for this section is what Seth is using. He's using an equation based off of the slope formula, m equals y2 minus y1 divided by x2 minus x1. When you rearrange this, like we did in section 1-4, you'll get the point slope form of a line. Y minus y1 equals to m times x minus x1. Now the y2s and the y1s, x2s and x1s have been renumbered a little bit into just x1, y1, and a generic x and y. But it's essentially the same thing. I want to draw arrows to the variables that you need to find. Whereas the other variables, x and y, are just generically there. This is called the point slope form. You can pick any point you want. It doesn't have to be the y-intercept, like in the previous problem. This could be y1, x1 could be any point you want. Okay, that is the difference. Slope, intercept versus point slope form. Okay, let's move on to the next page. I'm going to skip number 1 here. We kind of actually describe the steps needed to find the y-intercept of the graph using the point slope form. Just keep in mind that the y-intercept is where x equals 0. Okay. From there you solve for y. All right, it's not too bad. Let's move on to example 2. I would like to do the one in the textbook first. Same as the one that we have right here, but they give you a little more information. La 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 la. They want you to write an equation of a line in point slope form with slope of 1/2 and passes through the coordinate point 3, -2. Okay, great. Let's get the equation out. Y minus y1 equals to m times x minus x1. Keep in mind we want to solve or plug in and figure out m, x1, y1. Let's plug the information in. We have a slope of 1/2. Great. And we have a random point 3, -2. That's your x1 and that's your y1. Plug that in. Watch out for those negative signs. Right there, that minus sign is part of the formula, and that negative is part of the number 2. Okay, clean it up. Double negatives become positive right there. And ladies and gentlemen, there's your answer. Notice something interesting about the point slope form of the line. Things have to be backwards with y1 and x1 when you read it. All right, that was just plugging numbers into the formula. That's given to you directly. The example 2 in your note taker is a little different and has a little extra work you have to do. Unfortunately, you can't just plug it in because they don't give us a slope. You have to figure out what the slope is. We'll do that in a second. Let's write down our formula. Y minus y1 equals m times x minus x1. We don't know what m is. So we're going to have to figure that out. Off to the side, using the slope formula. It's rise over run, folks. I'm going to plug in that point and that point. The first point will be 0.1, and the second point will be 0.2. Just plug it into this formula. Okay, y value of the second point minus the x value of the, minus the y value of the first point, double negative right there, x value of the second point minus the x value of the first point. Watch out for those negatives. Oh no. There it is. -4/5 is the slope. We need to put that right into my equation over there, -4/5. All right. You just have to fill in the rest of this equation. Now, what do I do for x1 and y1? You actually have two choices. You can plug in the 0.1 or 0.2. They both work. It doesn't matter. So I will take this answer. Y plus 1 equals to -4/5 times x minus 2. And that's for the first point, 0.1. Or I will take the other answer. Y minus 3 equals to -4/5 times x minus minus 3, which is a double negative, and those are two answers. Okay, this is if you chose 0.2. Yay! Those are actually the same. They may not look like it, but if you simplify them and just rearrange the furniture, these are actually the same equation. All right, next page. Let me know if you have any questions. Sketch the graph of a linear equation in point-slope form. Sketch the graph of y plus 2 equals 1/2 times x minus 3. Now we've got to work backwards here. This is a little tricky. Let's go ahead and put in our coordinate plane. Made of axes here. Remember, this is point-slope form. You have to compare to the equation y minus y1 equals to m times x minus x1. We have to extract the point and the slope from this equation in order to graph it and be done. All right. Obviously, I see the slope right there is 1/2. Yay. It's going uphill from left to right. A random point is buried in here. x1, y1. x1 right there is, you got to think of it backwards, +3. Remember the formula is minus, okay? So when you put it in, it will be -3. y1, you got to think opposite of +2. That would be -2. If you throw that -2 back into the original formula, you'll get a double negative, which becomes positive, the original problem in the first place. Ladies and gentlemen, there they are. Slope is 1/2. The random point is 3, -2. Let's plot that. 3, -2. Okay. From there, we are going to need another point to connect to and create the line. Slope is 1/2. Go up 1, then 2 over, bam. You just created that particular line. I'm going to actually extend the slope a little bit and call this my equation of a line graphed on the coordinate plane. There it is. There it is. Okay. All right. Any questions about that? Think opposite now. So we're going to show you those two numbers we just got came from here. Okay. There's your double negative right there, and there's your positive 3 right there. Number 4. Rewrite the point-slope form equation from example 4 in slope-intercept form. What does the y-intercept represent in terms of the situation? Okay, so a moment ago, we graphed equation y plus 2 equals to 1/2 times x minus 3. We want to put it into slope-intercept form. Okay, that's what we're trying to do. Y minus y1 equals to m times x minus x1. We need to get it to y equals mx plus b form. And the way to do that is isolate, simplify, and solve for y. All right. Point slope form to slope intercept. All right. So I would highly recommend isolating y first. Let's move the plus 2 to the other side by subtracting. And then what we'll have is a situation where we need to distribute, simplify, and clean it up. Distribute that 1/2. And you notice that we need to combine some numbers that are stubborn, fractions. I'm going to convert the minus 2 and I need a common denominator of 2, so I need to multiply top and bottom by 2. That will give me y equals 1/2 x minus 3/2 minus 4/2. Negative 3/2 minus 4/2 is y equals 1/2 x minus 7/2. Okay, there it is. What does the y-intercept represent in terms of the situation? This is where the graph crosses the y-axis. It's an improper fraction, but if you convert it to a mixed number, it's 3.5. All right, quick summary about the two different forms that we've learned so far. If you are given a point and a slope, everyone suggests you use point-slope form. If you're given a slope in the y-intercept, you use what you did the previous section, slope-intercept form. Good job. All right, let's move on to the last page. Here we go. Essential question: what information does the point-slope form of a linear equation reveal about a line? Literally the point and a slope. All right. Let's go ahead and do number 5. Great. Write the equation of a line in point-slope form that passes through the given point with the given slope. Easy. Here we go. Y minus y1 equals to m times x minus x1. Plug the information in and you're done. 1 comma 5 is your random x1, y1. Same with the second half over here. Just plug it in and just be done with it. Here we go. 5 and 1. That's it? That's too easy, Mr. Chan. Yeah, that's it. And the second one as well. Oh, wait. Forgot to actually put in the slope, didn't I? Ha 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 ha. -3 right there. Whoops. Sorry about that. All right. Slope for the number 6 is 2, goes right there. And the random point, I'll go ahead and put that in, is -4, +3. You can actually clean that up nicely. This is going to be y minus 3 equals to 2 times x plus 4 because of the double negative. And number 6 is done. All right, number 7 and number 8 are exactly the same. They have one twist, like in the example, they don't give us the slope. We have to find the slope first for both of them. I'm just writing down the formula for both of them. The difference in y's over the difference in x's. Just plug it in, right? And when you're doing this, make sure you put in the right numbers in the right spots. All right. y2 minus y1 over x2 minus x1. For number 7, this gives me 4 over -1 as my slope. Oops, did I make a boo-boo somewhere? Oh, I think I did. Yes, thank you for catching myself there. It's 1 minus 4. Gotta be careful there. There it is. Okay, we now are ready to write down our 2 answers, depending on which one you choose for your point. You actually have 2 choices here. So using y minus y1 equals to m times x minus x1. Plug the information in for the first point. Y minus 2 equals the slope we just got times x minus 4. There's my first answer for the first point. Okay? Or if you use the second point, this is what the answer will be. Y minus 6 equals to 4 over -3 times x minus 1. Ooh. Number 8's the same. Let's plug the numbers in to find out what the heck the slope is. Gotta watch out for those negatives though. -4 minus 8 over 7 minus -2. That's -12 over +9. That equals to, no way, the same slope from the previous one? Very strange. Very strange indeed. Coincidence? I don't know. All right, let's plug it in. All right, so the slope was -4/3. And we'll put in the first point, -2, 8. -2, 8. And when you clean that up, you'll get this. After the double negative becomes positive. Okay. And if you happen to plug in the other point, you'll get this as the answer. They both work. They're the same line. Trust me. Let's plug that in. All right. And that second point is 7, -4. 7, -4. And when you clean that up, you'll get y plus 4 equals to -4/3 x minus 7. Whew. All right. Number 9 involves converting from point slope to slope-intercept form. We'll just have to distribute and clean it up, and that's it. Basically, distribute the -5 first. And eventually we need to isolate y, don't we? Let's isolate y by adding 6 to both sides. That's it. Y equals -5x plus 1. Yay! Whew. I don't know about you, I'm ready to finish up with number 10. A couple of graphs that we have to come up with a point slope. And they give us the point to plug in. Let's do it. A lot of times these problems you can just figure out by inspecting. So we have our point for both of them, x1, y1. And the last thing we have to figure out is the actual slope from identifying the graphs on the left there. So for 10a, I just randomly threw in another point that looks like it's on that line in the grid system. Looks like my slope, which we are calling rise over run, equals to, well, the rise is not going up, it's going downward. That's -2. And the run is +1. There it is. There's my slope. And my random point. Plug it in and you're done. And that random point is 2, -1. Okay, a lot of negatives, we want to clean that up. And there's my answer. Let's go ahead and do B, the last one. Same way. Yay. All right. Slope. Oh, okay. Let's try this point right here. And to go from one point to the other, my rise is +2 over 3. There's my slope, 2/3. And let's put in my random point, 3, 1. Gosh, not bad. We are finished. Wow. All right, that's another session. Thank you very much. If you have any questions, please let me know. Talk to you later. Bye-bye.